everyone, this video is about definitions, some examples, and vocabulary regarding similar polygons. So it's more informational versus practice. So the first thing we have is our vocabulary. Two polygons are similar if corresponding angles are congruent and the corresponding side lengths are proportional. So for example, if I have, say, two triangles, and I'll make this one smaller, and if this is 3, 3, 3, and this one's 1, 1, 1, our angles would be the same. These are equilateral triangles, so our angles would all be 60 degrees. So all the measures of the angles. So they're not congruent, even though all the angles are the same. We have angle, angle, angle triangles, but they're not congruent because the side lengths are proportional. The scale factor of two similar polygons. If two polygons are similar, then the ratios of the lengths of the two corresponding sides is called the scale factor. And we have some examples on that. So, for example, we're using similarity statements. We list the pair of congruent angles. So, since it's stating that these two triangles are congruent or similar, then that means our angles are congruent. A is congruent with D, B, just like I said before, B is congruent with E, and C is congruent with F. All right, so that's this part. And check that the ratio of the corresponding lengths are the same. So basically what they're doing is they're just saying, for example, this one, AB and DE. So that's 10 over 15, reduce it 10 and 2/3. If you check the others, they all should equal 2/3 because that's going to be your scale factors. So the ratios in part B are equal, so AB over DE equals all these proportions here. So, and you're looking at this. AB is to DE as BC. You just look at your words here, EF, and then AC or CA goes with DF or FD. So you can just look at this right here and fill this part out. All right. So basically, given that we have two similar triangles, list the pair of congruent angles. So let's do that. We have, I'm going to write it, triangle PQR is congruent to triangle XYZ. So that means these two angles are congruent. They have them written there. So I'm just going to mark it here. Angle Q is congruent to angle Y, and angle R is congruent to angle Z. These have to go in order. All right? And then for the sides, you do the same thing. They have them listed, but I'm going to do it this way. Whoops. So I'm going to write it again. PQR is not congruent. This should be similar. Sorry about that. Is similar to triangle XYZ. So that means PQ over XY equals QR over YZ. And then also this equals, and we'll just do this, RP and ZX. Do you see how it goes in order? All right, then we have an example. We have to identify all the congruent angles and stuff. So the corresponding angles are congruent. And you can just look at this picture. Everything is marked. show that the lengths are proportional, so I'll just do one. Let's look at AD equals 12 and JD equals 21. If you divide both the numerator and the denominator by 3, we get 4 divided by 7. And then you can do all the side lengths, and you should always get 4 over 7, which is here. So the ratios are equal, so the corresponding side lengths are proportional. And this is your scale factor. All right, and the next one, here's another example. The triangles are similar, so the corresponding side lengths are proportional. And we need to write a proportion. And we can write them different ways. Of course, we did that in the last lesson. So BC is to RS. So we have 12 is to 24 as CD. So CD is 13 is to X. And you cross multiply, you get 12X equals 312. And you just solve for X. Again, they have it. X is 26. So that just regards your similar polygons or triangles in this case. All right. What is the scale factor? I'll just do one of these. I'll do FG, and I'm looking at this FG with LM. So FG to LM. So FG is 15 and LM is 12. Divide the numerator and the denominator by 3. And that's going to give you, well, I should have flipped this. So, because they have LM first. So it should be LM. This equals 4. And FG is the second one, and that is 5. So that's your scale factor. You can do some more. You could do NP to HJ, and you would still get 4/5. Now find the value of X. Well, we know the scale factor is 4 to 5. So to find this, we're just going to do 4/5 equals, and we're going to do GH with MN. So GH is 40 and LM is X. So when you cross multiply, you get 4X equals 200. 5 times 40 is 200. Yeah. And so X would give you not 32. So let's see what I'm doing here. All right. So basically, we want to find the value of X, which is here. That's MN. And MN goes with GH, which is 40. And our scale factor is 4 to 5. Oh, I see what I did. All right, so cross up. So MN equals 160 divided by 5, which gives you 32. Now here's a theorem we have. If two polygons are similar, then the ratio of the perimeters is also equal. So if these two polygons are similar, then you can just add up the side lengths and the proportions, the corresponding side lengths will equal. All right, so we'll do an example of that. So we have a basketball problem. A larger cement court is being poured for a basketball hoop in place of a smaller one. The court will be, so this will be the larger one here. The court will be 20 feet wide and 20 feet long. The old court was similar in shape, but only 16 feet wide. So find the scale factor of the new court to the old court. So what we have is the feet and the width. So to the new court, which is 20, and the old chord is 16. Divide both of these by 4, and you get 5 over 4. That's what they did here. So the new chord's perimeter is going to equal, the perimeter is 2L plus 2W. So the new chord's going to be 2 times 20 plus 2 times 25, and that gives us 90, which they have here. Now, it says use the theorem to find the perimeter of x in the old chord. So what we know, the scale factor is 5 to 4. So we go x, well, this is 5 to 4, and 5 goes with the 90, and 4 goes with the x. So when you cross multiply and simplify, you get x. Oh wait, this is 90 to x, sorry. 90 to x. So when you cross multiply, which they've already done, you get 72. So basically the perimeter of the old court is 72 feet. So they did the perimeter, we did the old to new here. So old court, so this is new court, new to old. So new is, the perimeter is 90, and we don't know the old. New is the 5, and old is the 4, and that's where you came up with the formula there. And it says corresponding links and similar polygons. So it's the same thing that we've been talking about. So if two polygons are similar, then the ratio of any two corresponding links of the polygon is the scale factor, is equal to the scale factor of the similar polygons. So basically, we have two similar triangles here. Find the length of the altitude, which is JL or GL, this one right here. So this right in here. So first of all, we have to find the scale factor. So what I want to do is look at FH, and that goes with JK. So FH goes with JK. And they just merely added up the numbers, so that's 8 plus 8 divided by 5 plus 5. And when you do all that, you get 8 over 5. So that's the scale factor. Because the ratio of the lengths of the altitude is similar to the triangles, in similar triangles is equal to the scale factor, you can write that GL to GM equals 8 to 5, because that's your scale factor. All right? And then, so write the proportion. We don't know GL. That's what we're looking for. So we have GL is the 14, is 8, is the 5. And you cross multiply and solve. Cross up like that. And you get GL equals 22.4. All right. And the last note is we need to find the perimeter of which triangle? This one. So first of all, let's find the scale factor. So we know WX goes with PQ. So it's PQ to WX is the scale factor. So that's going to give you PQ is 72 to 40. And when you reduce that, you're going to get 72 divided by 40 is 9 to 5. Basically, you're just dividing each of these pieces by 8. So divide by 8, divide by 8. So that's your scale factor. All right, and so now we can find the other side. So we have 9 to 5. PQ is the larger one. So this is the first one. So 9 to 5 equals, and I need to get WY. So I know the P one, I'm just going to write that this is your PQR, and this one is your WXY. So this one's 81, and we're looking for this length. So when you cross multiply, I can rewrite this. I'm going to rewrite it as 5 to 9 equals X to 81. And I cross up here, I get 81 times 5 divided by 9 equals X. So 9 goes into 81 9 times. So X is going to be 45. So this length is 45. And I'm going to do the same thing with the this side. So I'm going to do my triangle PQR and then my triangle WXY. So that's 9 to 5, and has the PQR 63 to X. So I'm going to go ahead and flip these again with my reciprocal property. Cross up, and that's going to give you 63 times 5 divided by 9 equals X. So 9 goes into 63 7 times. 7 times 5 is 35. So this is 35. Now to find the perimeter, we merely just add everything up. So it's going to be 40, the perimeter, equals 40 plus 45 plus 35. So these two add up to 80. And so 80. So 40 plus 80 equals 120. So that's 120 there. And to find the length of the median, you kind of do the same thing. Let's see. It's going to be, let's see, the median of this. So if this is 24, this is 24. So we have 16 is to 24 as X is to 39. So I kept the denominators is this triangle. My numerators is this triangle. And you cross multiply and solve, and you will get 26. And that's it. Thank you. Have a nice day. Bye-bye.